lesson on this. Okay, so VSEPR is going to be valence shell electron pair repulsion theory. Okay, what is going to be so important about this is we need to know the lone pair and lone pair repulsion is greater compared to lone pair and bonding pair, and it's greater compared to bonding pair and bonding pair. Okay, this is the main thing that you need to know about, okay, VSEPR theory. Now, so it means the repulsion is going to be greater. Okay, so now let's actually look at some of the examples, right? For example, if you have two bonding pair, okay, if you have a compound that has only two bonding pair, okay, what is going to be the shape? Okay, example of those compound is going to be BeCl2. So if I want to actually draw BeCl2, beryllium is going to be group 2. Okay, so they have two valence electrons. So when I draw, I will actually draw something like this. You have Cl, Cl, X, X. Okay, I have everything. I just put it over here. So when I determine the shape of molecule, I will just determine based on the center atom. Okay, the center atom contains how many bonding pairs. So the center atom contains only two bonding pair over here. So this is going to be two bonding pair. Ignore, okay, the lone pair surrounding the Cl, because I want the bond angle surrounding Be and the Cl. Okay, so when I draw, it's going to be BE, okay, BE, and then it's going to be this kind of shape, okay. The bonding pair and bonding pair, okay, the idea is when you actually draw the shape of molecule, they like to rearrange themselves so that you have the maximum repulsion or the maximum bond angle between them, so that you minimize the repulsion, okay, to minimize the repulsion. So they prefer to stay away from each other. So this is going to give you the bond angle of 180 degrees, and this molecule is going to be known as linear. Okay, linear, and linear is a 2D molecule. So we also actually say that this molecule is a planar molecule. Okay, it's a planar molecule. Okay, so the name you need to know. Okay, the name is going to be linear. Okay, let's actually move on further. Okay, if you, what happens if I have three bonding pair? Okay, three bonding pair. So if I have three bonding pair, okay, quite simple. Okay, let's actually look for something that has a group three valence electron. Okay, boron is one of the examples. So let's actually look at this example, BF3. Okay, boron is going to be group 13. Okay, so when I draw, I will draw something like this. 1, 2, 3, F. Okay, so of course, when I want to draw everything, I'll just draw very fast. Now, this actually tells us about, okay, three bonding pair. Okay, if you have three bonding pair, the best way to rearrange them, okay, is going to be in this form: B, F, 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 with a bond angle of 120 degrees. Okay, so the name of this, okay, is known as trigonal planar. Okay, planar. And this is also another example, okay, of a planar molecule. You can actually see that it's already written in the name itself. It's a planar. Planar means can be formed on a piece of paper. Okay, can be lying on a single plane. Yeah, planar. It's not 3D. It's just 2D. Okay, let's move on further. Okay. What happens if you have four bonding pair? Now, four bonding pair is the time that when you actually start to explore 3D structure. Okay, when you explore 3D structure, it means now these molecules are going to be non-planar. Okay, so this one is non-planar because they are going to be 3D. Why non-planar? Because the bond angle, okay, will be much more greater if you explore the 3D, because we want the bond angle to be the biggest, right? Like if you just arrange them just like this, 90 and 90, okay, that's going to be the angle is still small, okay, because we can actually rearrange, like for example CH4, okay, we can rearrange CH4 in this structure. Let's say, for example, H over here. Okay, when you have another H, we can actually arrange it in this way, and then you arrange it this way. Okay, so I will start to draw this way. So what does it mean? The two lines over here is just telling us that it is going to be on this particular plane, and this is going to tell us that it is coming out from the paper, is coming out from your iPad, coming out from your screen, and this one is going to tell us that it's going behind the screen, behind the iPad. Yeah, so this is going to be a 3D structure, and the bond angle, if you measure, is going to be 109.5 degrees. No longer it's going to be 90 because we want the maximum bond angle, and this shape is going to be known as tetrahedral. Okay, tetrahedral, and I already mentioned it's going to be non-planar. Now we do have, okay, some like a variation, okay, of this 4 bonding pair. So the other variations is going to be 3 bonding pair and 1 lone pair. Okay, 3 bonding pair and 1 lone pair. The structure looks like tetrahedral, but there is a different structure because if you have, like, for example, ammonia. Okay, ammonia is going to be group 15. Okay, sorry, and nitrogen is going to be group 15. So when I draw nitrogen, that's going to be 1, 2, 3, 4, 5. Okay, so if you have hydrogen, they will share it this way. Okay, the bond angle that we are going to actually talk about is going to be slightly different because, okay, according to this Vsepr, okay, the bond angle will be different because, okay, this is going to be the lone pair. Okay, so the lone pair will actually exert a greater repulsion because lone pair and bonding pair, okay, the bond angle should be much more greater. Okay, they will repel more, and this will actually make this particular angle to become slightly smaller. Okay, slightly smaller. So if I actually put it in this, let's say if I want to redraw it again, so how do I redraw this? It's supposed to be like this, okay? And then this one, okay, will be smaller, okay? This one will be coming out, okay? And this one is going to be going behind, okay? So this one, okay, is going to actually tell us that this structure is going to be pyramidal. The shape is going to be pyramidal. And then the bond angle compared to just now was 109.5. Now, because of the presence of this lone pair, okay, the 109.5 is going to be pushed much more smaller, okay, because of the lone pair. So the bond angle that we are talking now is no longer 109.5. The bond angle now is going to be 107 degrees. Okay, please memorize. Okay, it's a pyramidal shape. Now, the next part, okay, is going to be, let's actually move to another variation. The another variation is going to be 2 bonding pair and 2 lone pair. Okay, according to this variation, okay, the example given is water. Okay, the center atom is going to be oxygen, group 16. So when we draw, okay, it will be like this, 2 lone pair. Okay, and then we have hydrogen, hydrogen, so 2 bonding pair over there. So what happens is, okay, this is going to be the lone pair and this is lone pair. The repulsion is way greater. Okay, so they will actually start to repel way more. Okay, so when they actually repel more, okay, what happens is going to be they will actually have a stronger bond angle over there. So this strong, bigger bond angle over there is going to actually make, sorry. Okay, this is going to actually make, okay, the angle, okay, over here to be much more smaller. Okay, so there is more repulsion. Okay, there is more repulsion between lone pair, and also the repulsion will actually will have the repulsion from bonding pair and lone pair as well. So whatever it is, okay, the bond angle over here will be way smaller. So if I actually put this down again, okay, it's going to be something like, okay, hold on. So if I actually put it over there, it will look like, okay, the shape is going to become like bent. Okay, the shape is going to become like bent. Okay, so let's say, okay, O and O. you will get something like this. Okay, so the bond angle is going to be way smaller than the previous one, which is going to be, the earlier one is 107. So now it should be way smaller than 107 because of the more repulsion. So the bond angle that we are talking about here is going to be 104.5. Okay, and then this one you can memorize the shape. This shape is going to be bent, or we call it non-linear, or you can actually say V shape. So all these are accepted in your CIE. Yeah. So let's actually move on further. Okay. Now all the variations we have covered. Okay. And then another one, let's actually discuss here. For pyramidal, it's going to be, again, this one is going to be non-planar because it's actually 3D diagram, non-planar. But here, okay, this one is a 2D diagram. So this one is going to be planar. Okay, take note of this. Okay, it's planar. Now, so the next variation is going to be the one that is going to be 5 bonding pair. Example is PCl5. Phosphorus is group 15. So P, okay. So just imagine if you have, okay, 5 bonding pairs surrounding the phosphorus. How do we draw? When we draw it this way. Cl come here, Cl come here, Cl come here. And then on top, okay, that's going to be another Cl. Going down, there's another Cl. So what is the shape of this? Okay, the shape of this is going to be known as trigonal bipyramidal. And then what is going to be the bond angle? Okay, the bond angle, there are two angles. One is 120 degrees here. Another one is the bond angle between this and the triangle. That's going to be 90 degrees. Okay, so two angles over there. We will move on. Okay, the last one is going to be 6 bonding pair. Okay, if you have 6 bonding pair, how do we actually draw? Okay, example is SF6. Okay, so sulfur. Okay, you have F, 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 F. I will draw something like this. Similar like just now, 2 will go up and down. So what is the bond angle of this? All of them are going to be 90. Okay, all of them are 90 degrees. And then this is going to be known as, okay, octahedral. Okay, octahedral. And the bond angle is going to be 90. Okay, of course, there are some variations. Okay, so if you have, like, for example, it's been asked in a CIE paper, if you have, okay, 4 bonding pair, okay, 4 bonding pair, let's say that's going to be A, and then you have another 2 lone pair, for example. Okay, so what is going to be the shape? Okay, the shape of this is going to be this is going to be what we call as a square planar. Okay, the shape is going to be square planar. And this is going to be square planar. So the bond angle is also going to be 90 degrees. Okay, just take note of this. Okay, so is there any question up to